Alright, these are your notes for section 10.1 on exponential functions and equations. And the first question here is, what is an exponential function? Well, an exponential function is a function with the variable in the exponent. Here's a couple of examples. This is an equation, y equals 4 to the x. Notice that the x, the variable, is in the exponent position. Now you could also have something like y equals 4 to the 2x, where there's more than one thing up in the exponent position, but the variable is still up there. One final one, y equals 4 to the 2x plus 1. Now we have a longer expression up there in the exponent, but it still has the variable. That's what makes an exponential function. The variable, the x, most of the time, has to be in the exponent position. Now the general form for an exponential function is y equals a times b to the x. Again, the exponent is in the the exponent is the variable. Now it's only on the b here. Okay, we have two different variables, two different numbers going on. We have an a and a b. There's a couple of rules that we need to remember. First one is that a cannot be 0. If a is 0, that cancels everything out in the problem. 0 times anything is 0. We don't have an exponential function anymore because it would be y equals 0, which is linear. Alright, so a cannot be 0. It can be positive and it can be negative, but it cannot be 0. The next two apply to b. b has to be greater than 0, which means it needs to be positive. b cannot be negative. b can also not be 1. If b is 1, 1 to any exponent is always 1. It's not going to change. It's going to stay the same. So we'd end up with a linear function again. Okay? If b is negative, when b is negative or 0, it doesn't work for our problem. If b is negative, our exponent, depending on what it is, will switch between positive and negative. So our equation, our graph, would look really weird. It won't look like an exponential equation. So just remember those rules. They will come up again, especially when we're solving equations, writing equations, when we're graphing things. Okay? A cannot be 0, b has to be positive, and b cannot be 1. Alright. One other thing I'm going to give you, because this is important for writing an exponential equation, is the y-intercept. Remember, the y-intercept is where it crosses the y-axis, and it is always 0a. That's the same a from the general form. So whatever a is, the y-intercept is always 0, that number. Okay? Now, solving an exponential equation, what you want to do is get the same base on both sides. Okay? So you may have to rewrite one or both sides in order to get the same base. We've got 3 examples here. All of them require different things about rewriting the base. So let's start with this first one. First one is 3 to the 2n plus 1 power. We know it's an exponential because 2n plus 1, the n is the variable, and that's in the exponent, equals 27. What we want to do is we want to get the same base on both sides. So we need a base of 3. So this side's not going to change. The left side won't change. 3 to the 2n plus 1 equals, and we can rewrite 27 as 3 to the third. That way we have the same base on both sides. That's what you want. Now when you have the same base on both sides, they just cancel out. And you're left with the exponents equal to each other. Okay? So it's really nice when you get the same base because all it does is cancel out and you set the exponents equal. Now we have 2n plus 1 equals 3. We solve it like we normally would. Subtract 1. So 2n equals 3 minus 1 is 2. Divide by 2, so n is 1. There's the answer to the problem. Now you could plug that in and check. 2 times 1 is 2, plus 1 is 3, and 3 to the third does equal 27. So it does work out, and that's what you want. Next problem. We have 3 to the 5x equals 9 to the 2x minus 1. Notice on this one we have variables on both sides. We know they're exponential because the variable is in the exponent, but this time there's exponents on both sides with variables in both of them. Now we want to get the same base. We have 3 again, and this time we have 9. So we're going to rewrite our 9 so that it becomes a base of 3. 3 to the 5x isn't going to change, but 9 is really 3 squared, and then to the 2x minus 1. Now it's a power to a power here. And if you remember, when we have a power to a power, we multiply. Okay, so you're going to multiply 2 times 2x minus 1. Really, you're going to distribute that 2 through. Okay, but make sure it goes to both. Common mistake is to only take it to the first one. It has to go to both, so make sure you distribute. We end up getting 3 to the 5x equals 3 to the 2 times 2x is 4x, and 2 times negative 1 is negative 2. Now our bases cancel, and we're left with 5x equals 4x minus 2. Subtract 4x from both sides. 5x minus 4x is x equals negative 2. So there would be the answer to our problem, negative 2. Now again, if you want to check that just to make sure that you've got the right answer, we plug that back in. 5 times negative 2 is negative 10, and then we'd figure out what 3 to the negative 10 is. And then 2 times negative 2 is negative 4, minus 1 is negative 5. If we go into our simplified thing here, simplified where we've rewritten the 9 as 3 squared, we end up getting 3 to the negative 10th, which is what we had on the other side. So we know we did it right because the left and the right both end up being the same thing. Last example here. This one's got a fraction. This is the one most people don't like. Okay, we have 2 to the n plus 4 equals 1 over 32. Now we want the same base on both sides. And here's the catch. That 1 over 32, we're going to leave it as a fraction for the time being, but we can rewrite 32 as 2 to the 5th. So right now we have 2 to the n plus 4 equals 1 over 2 to the 5th. We do have the same base. Our problem, though, is that this is in the denominator. We want to take it to the numerator. So to do that, we're going to make it 2 to the negative 5th. Because remember, if we have a negative exponent, to get it to be positive, we just move it to the bottom. So if we have a positive exponent, we could switch it to the other one, either the numerator or the denominator, and just make it negative, and that would be equal to it. So in this case, we had a positive exponent in our denominator. We've moved it to the numerator to make it negative. Now we have the same base on both sides, so they cancel. N plus 4 equals negative 5. Subtract 4 from both sides. So n equals negative 5 minus 4 is negative 9. And there would be the answer to our problem. To check it, we can plug negative 9 in. Negative 9 plus 4 is negative 5. And 2 to the negative 5th does equal 1 over 32. So we do get the right answer when we check it. Now those are solving exponential equations. For these, or again, you'll have to rewrite either one side or both sides so that they have the same base. All these examples here, we've only rewritten one side. Now you may have to rewrite both sides, and that's fine. Just remember what we've done here. If it's already to a power, you need to distribute it through. You need to multiply and distribute it through. If it's if it's on the denominator of a fraction, you need to move it up and make it a negative exponent. Okay? The last thing we're going to look at in this video is how to write an exponential equation. Now, what you want to do when you write an exponential equation, it's kind of like writing an equation in slope-intercept form. The difference is it's an exponential equation. So it's the same general idea. We're going to follow kind of the same steps. It's just we have a different form it goes in. Okay? So it's like writing in slope-intercept form, but it's in a different form. Your first step is to plug in values for a, x, and y. Now what they'll do on these types of problems is give you 2 points and ask you to write an equation. One of those points will always be the y-intercept. So you will always get the y-intercept. Alright? The reason we give you the y-intercept is because it's 0a. So you will always have a for these problems. Now any other point on your graph could be x and y. So you'll have the y-intercept, which gives you a. You'll have another point which gives you x and y. What you need to do, the second step, is to solve for b. Alright? Once you've solved for b, you're going to rewrite it in y equals a times b to the x, but a and b will be the only two that get values. X and y will stay variables. X, y stay variables. Okay? In that third step. So let's look at our example. This isn't as hard as people think it is. Okay? We have 0, -1, and 2, -9. Now this first one is the y-intercept, because it's 0 and a number, which means this, the -1, is a. In our other point, we get x and y. Just make sure you take the x from the right part of the coordinate and the y from the correct part of the coordinate. Don't get them mixed up. Now we plug them in to standard form. Y equals a times b to the x. Well, y is -9 equals a is -1. We don't know b, but b is to the second power because that's what x is. We're going to solve for b, so we're going to divide by -1. -9 divided by -1 is +9 equals b squared. So we'll square root both sides. Remember, when we square root, we need to take plus minus. Okay, we want all possible answers here. So those cancel. Square root of 9 is 3, so we end up with b being plus or minus 3. Now here's the catch. Remember, b has to be greater than 0, which means b cannot equal -3 because that's a negative number. So the answer here is b equals 3. That's what we get for b. Now, common mistake is to stop here. You found b and you stop. You can't. Remember step 3. Step 3 is to rewrite it so that it's in y equals a times b to the x form. And a and b are your values. X and y stay variables. So y equals, a was -1 times b is 3 to the x power. And there would be the answer to the problem. Y equals -1 times 3 to the x. Now, those are your notes on exponential functions and exponential equations, and this is how to solve and write the equations. If you have any questions, go back and rewatch the video. If you still have questions, bring them to class next time.